Okay, so this function has only one horizontal tangent. Okay, that means, so horizontal tangent happens when the derivative is equal to 0. There's only one. That means for this equation, only one x value exists. Does that make sense? Okay. So let's differentiate that. Okay. And you get 4x cubed plus 6 a minus 1 sorry 4 x plus 4a. Okay, so let's plug in okay, actually, so this, for this to equal to 0, there's only one x value that satisfies this. Let me simplify that a bit. Let me divide both sides by 4. Okay, so let's interpret this as a cubic function. A cubic function with one root must be something like this. Right? You just pass through one point. So typically, cubic can do this, have 1, 2, 3 x-intercept, as well as you can have 1, 2 x-intercept. But it must be this one here. So right off the bat, I can see that if this disappeared, there'll only be one value of x. If a is equal to 1, that will disappear, right? Then you get x cubed plus 1 is equal to 0. And how many x value do we have? Negative 1 only, right? Okay, so also another possibility of this only having one x-intercept is that if this graph is constantly going up and never coming back down, like this one, right? Because that means this graph always, so I want an a value which ensures that this is always positive, always going up. Okay, and we can check that from, right? It's actually always increasing. Not this is positive, is increasing. That means the second derivative always needs to be positive. Right? If I want the derivative function to be always going up, the second derivative needs to be positive. Does that make sense? Okay, look. If that doesn't make sense, think about it this way. If I want the function to be increasing, isn't it true that if this is positive, this is the function is increasing? So it's the same. If I want the first derivative to be increasing, if that's the derivative of this, which is the second derivative, if that's positive, then this is always increasing. So I can say, let's differentiate that one more time. And I get 3x squared plus a minus 1. Okay, I want that to be positive. This is always greater than or equal to 0. X is greater than or equal to 0. Right? So x squared is greater than or equal to 0. So how do I ensure this is always positive? If a minus 1 is greater than or equal to 0. That means if a is greater than or equal to 1, this will only have one x-intercept because it's strictly increasing. It's always going up. It never turns like this. So you will now have another x-intercept. So from guess and check, I got this. And also, sorry, not this one. Here, I got that. And from the second derivative, I got this. So this is the answer. All the values that are greater than or equal to 1 will ensure that it'll only have one horizontal tangent.